All right, so welcome back to our new chapter. We're going to talk about chapter 2, and we're going to start with looking at some graphs. So the first thing that I want you to do is get yourself all ready for notes, and we're going to get started. So we're going to start with some vocabulary in this case. We're going to talk about, the first thing is you're often going to be asked about domain and range. Now hopefully this is pretty familiar from previous years. The domain is the possible values for the independent variable, meaning the variable that's usually x. Now an example for this might be if I have the function, so f of x is equal to root x, then the domain would be everything from 0, we include 0, so you'll often see this written in scientific notation, to positive infinity, because you can't plug in negative numbers. So that's one way to write the domain of a function. Now the range is the values of the dependent variable, which is usually y, which would have, in this case, we would have the same range as domain. Now if we had something like f of x is just equal to x, then the range would be negative infinity to positive infinity. You can have any number for that. So if I'm looking at this problem here, find the graph, using the graph of f of x. This is called a piecewise graph, which just means it's in pieces. This parabola is one piece, this horizontal line is the second, and this line with slope 1 would be the third piece. Find f of negative 2, f of 2, and the domain of x and the range of x. So I'm going to start with f of negative 2. What this means here is that x is equal to negative 2, so then the question becomes, what is the function equal? Well, negative 2 is right here. So if I look at what the function equals, that's 4. So f of negative 2 is 4. Similarly, f of positive 2 is here. If I look here, I end up going through two pieces, but only one of them is filled in. This is the open boundary, so this is the one I actually care about for the answer, which is 3. Now, for domain and range, the domain, we can see it's all of this, so that's negative infinity. We also have this filled in, we have here, and then it goes on forever this way. So in this case, the domain is going to be negative infinity to positive infinity. Anything can be in the domain for x. Now for y, for the range, it goes on everywhere here, right? We've got all these y values, everything in here, but it ends right here. There are no y values less than that. So then the range in this case is 0. We are including 0, since it does go through at the origin, to positive infinity for the range. So this is a way that when we have the graph already done that we can answer some of these questions. Now you will also be asked to graph some things by hand. One of these is a parabola. Lines and parabolas are going to be the main ones that I expect you to graph accurately and consistently by hand in this unit. The remainder, which we'll talk about in our next lesson, you can use a calculator for. So when you talk about important points on a graph, there are a couple things you want to look for. Now, one that's always going to be important is the y-intercept. And this is where x equals 0. It's sometimes thought of as the constant term. That doesn't always work. So I always recommend, if you're not sure, it works for polynomials, it works for quadratics, it works for lines, but this isn't going to work for every type. So internalize this definition of y-intercept as well. The other things that are helpful to think about are slope, if it's a line. It's also important when we're talking about a parabola. We don't think about slope so much as we do about the vertex, right? If we're looking at a parabola, that is the point where it turns, if it's a positive one or a negative. And then you also might think about x-intercepts. These are also called roots. And this is where y is equal to 0. So when you're graphing, thinking about all these things is really helpful. Now, since this is a parabola, because it's quadratic, meaning that it has a degree or a highest exponent of 2. And we're going to start by finding the vertex. Now, if you remember from previous years, the vertex is a point, xy, where the point x value is negative b over 2a. Now it's like, okay, well, we don't see any b's or a's or anything like that. Well, this is coming from the same form as the quadratic formula, where you have a is the coefficient of the x squared plus bx plus c. So in this case, I might rewrite my quadratic as negative 1x squared plus 0x plus 4, which tells me this is my a, this is my b, and this is my c in just nice quadratic form. So when I'm using the formula, I end up with x is equal to negative 0 over 2 times negative 1. If 0 is in the numerator, that just means our x value is 0. So now we know our x value. Since it's a vertex, we are also going to want to find our y value, which we do by plugging into the formula y equals negative 0 squared plus 4, which is 4. So our vertex point is 0, 4. Now there's our vertex, which means we're going to start by graphing right here. And we have our point. Now, what you will do next, and what is often recommended, I'm just going to erase to give myself some space. Please don't erase, obviously, in your notes, is make a T-chart. And you usually you need 3, you want 5 points, and you're going to put the vertex in the middle, 0, 4. And I often find the easiest thing is then just to count down 2 numbers, 1, 2, or if the vertex was at 7, you just go 8, 9, and so on. Then in this case, negative 1, negative 2, and you want to plug in your values to find the rest using this formula. So for x equals negative 2, then it's negative 2 squared, so negative 4 plus 4 is 0. Negative 1 here, negative 1 times negative 1 squared is negative 1 plus 4 is positive 3. We know the vertex is 4, 1 is also 3, and 2 is 0. And we now have other points here, like this, and here, and we see that we have a negative parabola, and we can draw in our lines. Now, it's important when you're graphing the parabola that you don't make it like a V shape like this. It has a curve to it. What you want it to do is almost flatten out on top before coming back down. Now, if we look here, we have our y-intercept as well as our 2 roots. So this is a very helpful graph to have for this parabola. The last kind of graph that I would expect you to be able to do by hand is an absolute value graph. Now, the way that you want to do absolute value is you want to find where the 0 is. So that's where y equals 0, or the root. So in this case, we'll say 0 is equal to the absolute value of 2x plus 5. Now, since there's no positive or negative 0, we don't have to worry about separating these. So 0 is equal to 2x plus 5. Minus 5 divided by 2 is negative 2.5 is equal to x. So we're going to start plotting that. In this case, I'm going to, because I've got a half here, I'm going to plot my numbers every 2 spaces. So there is our root. And now what you can do is, once you've got the root, is you can graph the function inside of here. Because this is just going to be 2x plus 5. This is just going to be a line or it might be a parabola, because I'm asking you to do it by hand. I wouldn't ask you to do anything else. But do it lightly. Don't draw super dark. So in this case, I've got my +5 here. I've got a slope of 2. And what I'm going to do is, so I've got this line here. And for the positive stuff, right, because this is positive here, not x, positive, I can just draw that line in, because absolute value is no different with positive than it is with negative. Then for the other part, this side's negative. Absolute value can't be negative. So what we want to do is then that's where we take our turn, because if you remember, absolute value graphs look like V's. So we want to turn back upward, and we're still going to have the same slope, 2. And that's why it's nice to have the 0 there, because we know that that's where we turn. And then we still have the same slope, but now it's -2, and we turn back up. Now, hopefully this feels relatively familiar. I know this was a longer video, so get started on the homework, and then you might want to use the extra 30 minutes on Wednesday. I'll talk to you all later, and please leave me any comments or questions that I can help address as quickly as possible.